Alrighty, let's see what we got. Find the original type string, part 1, easy. Alice is attempting to type a specific string on her computer. However, she tends to be clumsy and may press a key for too long, resulting in a character being typed multiple times. It's pretty clumsy. Actually, does that even? Oh, okay. Although Alice tried to focus on her typing, she is aware that she may still have done this at most once. Now, what is clumsy that I find that I do is I hold down the shift too long. There's so many times when I will type, I think it's the, or T and H are capitalized. Or maybe H and I is capitalized in like him or something. Well, I think that's perfectly normal, not clumsy at all. Alright, although she may focus, she's where she must have done this at most once. At most once. You're given a string word which represents the final output displayed on Alice's screen. Return the total number of possible strings that Alice might have intended to type. Interesting. So A, B, B, C, C, C. So she could have intended to type that same thing, or 1 less B, or 1 less C. So 1, 2, 3. Okay, same thing. 1 less C, 2 less C's. I thought this was at most once. She may have done this at most once. Oh, the C's. I see. I see. It could be she just holds down and types multiple C's. But it's one occurrence of the multiple thing, but the multiple thing could have multiple letters. Yes, she could intend to type 1C. That's interesting that it's the most once that she does it. Okay, anyways, I guess the harder one might be like she can do it at any number of times. No. So there's only one option for that one. There's four options there. Okay, so every time there's a repeat, the number of strings is equal to the possibilities could be that she has any number of that letter from 1 to the number of repeats as a possibility. So I think it should be like A only has one possibility, B has 2 possibilities, and C has 4 possibilities. And I guess you're counting the additional ones. So flat line, there's 1 possibility that she types a string. A has 0 additional possibility, B has 1 additional possibility, and C has 3 additional possibilities. So 1 plus 1 plus 3 is 5. And then the baseline is 1, 0 plus 0 plus 0 plus 0 is 1. Okay. So I'll need to keep track of a streak of letters that are the same, and based on that streak, have a number of additional things. So the answer is always going to start with 1, and then I'll say the current letter is, let's say, something, and the current streak is current streak is 1. Then for every let's say for every letter in the string word, if the letter does not equal the current letter, the current streak letter, actually let's say it's equal to, then streak is incremented by 1, else answer plus equals the streak minus 1, and then streak resets to 1, and the current streak letter resets to this letter. Return the answer. What's wrong with this logic? Oh, whoops. Answer plus equals streak minus 1. Oh, yeah, I forgot the last streak. The last streak needs to be added to the answer. The last streak is not terminated. It's terminated by the ending of the loop, or ending, going to the end of the string, but there's no character at the end, so. Okay. I think this is random. I think I can probably try running again to see if it actually randomly makes it faster. Made it randomly slower. Come on, is there really? There might actually be a faster thing here that I can optimize. Seems pretty darn good. For every word, every letter in word. Every letter in word. If the letter's equal to the current letter, seek incremented. Otherwise, answer resets. Streak equals 1. I guess I could avoid having the current and just compare the letter to the previous letter if I use indices. Okay, let's try this. Let's just see how that plays out. So for every letter, actually I still need streak equals 1. For every index in the range of n, where n is the length of the word, starting at index 1. If the word at this index matches the word at index minus 1, then streak increments. Else answer plus equals streak minus 1, and then I need to do one last, return answer plus streak minus 1. Ooh. Oh, I forgot to reset the streak. That's pretty bad. If it matches, streak increments, answer plus streak resets to 1. Yeah. Alright, no improvement. Ha 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 ha. Alright, I'm about to give up. Yeah, this is randomly just going slower and slower. Even though they're all kind of the same speed in my mind. I don't know. I don't know. I think this is how I would naturally tend to decompose this problem. I think it's fine. Let's see, what is this? Oh, it's just incrementing. I see, I see. That's legit. Yeah, that's legit. I guess this is kind of a template that I have for problems that have streaks in them, or things that are related to streaks, where I just always create a streak counter and a streak a variable to store the character of the streak, and then I tend to create code based off of that template, where you have a for loop that goes through all the letters, and then you have a statement to change your streak counter or reset your streak, and then you have some other code to do whatever logic's necessary for the streak. But yeah, this is legit. Like, you could just not have that code, just do basic possible. Anyways, I'm fine with my setup. Walkthrough. This is gonna be so the calculation is based on the calculation of possible strings is based on how often a character is repeated. The character that is based on the frequency of repetition for a repeated character. Repeat character being something like AAA. Basically, the number possible increases by 1 less than the frequency of repetition. So, for example, AAA had, or something, a string that has, let's say, 4 A's, the 4 A's will increase, the 4 repeated A's will increase the number possible by 3. Because she might have intended just to have 1A, but the other possible things that she could have intended that are more than that one is the second A, the third A, and fourth A are just kind of redundant, or due to her typing issues. So you know, process will therefore be go over, okay, have answer baseline be 1 possible. Go over each letter, track current, well, technically this probably is, have variable for, this is how I would do it, for current streak letter and current streak count. Go over each letter, oops, over each letter where you one, if letter matches and have logic for comparing letter to current streak letter. If matches, increase streak count. If doesn't match, increase answer appropriately. And reset streak. Resetting a streak means changing the streak back to 1, the current streak letter being the current letter. And then finally, after loop, increment answer by last streak. As that doesn't happen in loop. Again, this is my version of the answer. There's technically a faster way of doing it without keeping track of the streaks. But anyways, time complexity is O of n. Need to do a loop with constant kind of calculations, constant work, to determine streaks. Need to loop over all letters of string. Space complexity, this is just O of 1. No additional space is needed. You have some constant variable space. Alrighty.